everyday, we do activities that involve physics, even in the simple ones. An example would be when we water the backyard. To the eye of a simple human, it would be only water coming out of a rubber tube. However, to a physicist, it has initial velocity, acceleration in the x and y axis, and all of this is part of a parabolic shot. Our objective is to compare the real position of a falling water against the numerical solution.
Estoy grabando. Ya.
Well, our theory and data of the PVC problem, okay? So we're going to start with the formulas. The formulas we used to solve this problem were initial velocity equals to the square root of 2 times the gravity times the altitude times the altitude. Yep, times the altitude. Okay. Now, for getting how much water does it falls from the PVC, we use the formula the area of the small hole where the water comes from times the initial velocity. Now, for getting the reach of the and how far does the water can go, we use the formula initial velocity times the square root, only one square root. Well, it's only one square root, okay? One square root of 2 times the altitude divided by the gravity. Okay, those are the formulas. Now our data. We got this data, okay? So now let's analyze it. All this data is the analytic data, and all this data is this data. This data and this data is the experimental data, okay? So initial velocity, we got it with the formula that I mentioned before, and this is the volume of water that got out at the second number 1. This is the area of the hole where the water came from. This is the height of the water. So at second 1, the height of the water dropped from 0.95 meters to 0.65 meters, and so on with all of these data. So we can see that, for example, at second 8, the initial velocity that the water got out from was 1.5, and the water that got out was 9.44 times 10 minus 4. Okay, and the height of the water was 0, and the reach of the water was 0.5 meters. Okay, so now with the experimental data, we got that at second 1, the distance was 1 meter and 40 centimeters. Second 2, we got that it was 1 meter and 30 centimeters. And so on, as you can see over there. Now let's compare. Let's do some comparisons. We're going to compare seconds times the volume, right? So now let's see. We can see that these are the seconds, and this is how the volume of the water that was getting out of the tube is going up, as you can see. So as the second passed by, the water that got out increased, as you can see. Well, actually you can say that it decreased because it obviously had less initial velocity. Yes. And now let's compare seconds versus initial velocity. Okay. As the seconds passed by, we can see that the initial velocity got started decreasing. So at second 2, for example, the initial velocity was 3.5711 meters per second. Now, the volume versus the altitude of the water. The volume that dropped was not constant, though the altitude of the water started dropping as the water got out. Now, the altitude of the water versus the reach. As you can see, the reach was started over here, so it means that it decreased. At the same time, the altitude of the water decreased. So if you can see, they are relationed. Okay, and now the volume versus the reach. So as the reach dropped, you can see that the volume decreased. The volume of the water that got out decreased. Okay. So my recommendations for this project would be essentially check the formulas twice, and once you check the formulas, do the math with extreme order. Otherwise, you're going to get lost in the process because there are a lot of there's a lot of math included in this project. Now, as for our conclusions, I could say that we definitely find differences between the theoretical results and the practical results. Alright? So this means that the analytical results are more accurate than the practical results of the water dropping. I think the analytical results were more accurate than the practical results, because the practical results we didn't have material specialized for measuring this type of problem. So I think that as a comparison, these data are more accurate than this one, and that the results obviously change because of the instruments that we use to measure the range and the time.